Okay, welcome back to my lecture series on theory of probability. We were actually onto the concept of permutation. In the last class, we have actually discussed the permutation of repeated things. Now, today we are going to discuss another special type which is very, very important. It is called circular permutations. That means when you are trying to arrange n things round a circle, right? Now, in how many ways you can do that? That's the most important thing. Let's say there is a circle and there are n things which are given. In how many ways you can arrange it? Now, that is very simple. Now, for circular permutation, if you draw a circle like this, let's say we draw a circle and let's say we have four things by which we, four things we want to, let's say we have the four alphabets of the English alphabet A, B, C, D. Okay, A, B, C, D. Now, in how many ways can I arrange this four alphabets A, B, C, D? Now, now how we can do that? What is the concept of this circular permutation? Now, the first thing that we should do in this types of arrangement is that we have to fix a particular alphabet here in this particular case. Now, since it's a circle, we have to fix a particular letter or alphabet. Let's say we fix the letter A here, and then we can arrange the remaining three letters B, C, D in whatever manner we like. That means there is no restriction on the remaining three letters. Now, in how many ways we can do that? We can certainly do that in 3 factorial ways, that is 6 ways we can do that. So, the number of ways of arranging these 4 alphabets round a circle will be factorial 3, which is 6 ways. And that is actually, if you generalize it, let's say now we generalize the situation. Let's say we have now n things which we want to arrange around a circle. Now, in that case, what we have to do, the concept is that we have to fix a particular thing. Now, since that particular thing is fixed at that particular position, the remaining n minus things can arrange among themselves in n minus 1 factorial ways. So, therefore, the total number of arrangement of n things round a circle which I have written here is n minus 1 factorial. So number of ways of arranging n things round a circle, n things round a circle will be equal to n minus 1 factorial. That n minus 1 is coming because you are fixing one particular thing, because in a circle you have to fix a particular thing, because that position cannot be changed, but the remaining n minus 1 positions can arrange among themselves in n minus 1 factorial ways. So, n minus 1 factorial turns out to be the total number of arrangement in case you want to arrange those n things round a circle, right? Now, let's come to some examples where we can use this concept of this circular permutation. Now, you can see that I've taken a couple of problems here. Okay, the first problem, you can see if you can look at it, that it says that a round table conference is to be held between delegates of 20 countries. Okay, there's a round table conference, mind it. So, that means it's a round table, so it's a circle basically. So, a round table conference is to be held between delegates of 20 countries. So, 20 countries, delegates of 20 countries will come for this round table conference, and in how many ways, question asked, in how many ways can they be seated if two particular delegates may wish to sit together? Now, if two particular delegates may wish to sit together, the first thing that we should do is that we will consider those two particular delegates as a single delegate. Okay? Now, once we consider two particular delegates as a single delegate, then how many delegates we are left with? We are left with 19 delegates, 20 minus 1, that is 19 delegates, because we are considering those two delegates which are always together as a single delegate. So, we are left with how many delegates? We are left with 19 delegates. Now, since 19 delegates have to be arranged around a circle, going by the concept of circular permutation, these 19 delegates can be arranged, 19 delegates can be arranged in how many ways? In 19 minus 1 factorial ways, that is 18 factorial ways. So, 19 delegates can be arranged in 18 factorial ways, right? 18 factorial ways. Now, once I have done that by considering those two delegates always as a single delegate which are always together, I have to also consider the case that the arrangement among the two delegates. Now, since the two delegates are always together, the arrangement among themselves will be factorial 2. Okay. So, the two delegates can arrange among themselves the two delegates can arrange among themselves, in how many ways? In factorial 2 ways. Now see, so therefore what is the total number of such arrangements that is possible? If I want to make a round table conference with 20 countries and 2 of them are always together, it will be 18 factorial into 2 factorial. Why? Because there are 18, for every 18 factorial ways of arranging those 19 delegates round a circle, there are 2 factorial ways of arranging the 2 delegates who are always together. So therefore the total number of arrangement in this particular case will be again by the fundamental principle of permutation, which will be 18 factorial into 2 factorial. So total number of arrangements will be, in that particular case, will be 18 factorial into 2 factorial, and that will give you the total number of arrangements possible in this particular condition, right? So is it clear? So this is the way we apply the concept of circular permutation, right? We can go into another problem where we have used the concept of this circular permutation. That is, if you look at the problem here, in how many ways can 4 art students and 4 science students be arranged alternatively at a round table? Alternatively, again it's a round table. So the whenever you get a round table or something like that, so the arrangement will become or fall under this circular permutation, okay, this particular category. Now in how many ways you can do it? Now this, now see, the arrangement that is asked in this question is only possible if they are sitting alternatively, because an alternate arrangement is asked. So now what we can do is that we have to fix any one of the, either one of the art student or either one of the science students first, because we have to arrange them in a circular manner. So let's say this is the circle, and let's say these are the art students A1, we name the art students A1, A2, A3, A4, A1, A2, A3, A4, right? And alternatively the science students will sit between the art students. So let's say it is S1, S2, it is S3, S4. Now this will be the arrangement. Now this is one such arrangement. Now you have to find out how many ways you can do that. Now whatever way you do, you have to fix any one of them. Either you fix up A1 or you fix up X4, any one you have to fix up. So let's fix up the first art student, right? So let's fix up the first art student. We fix up the position of A1. A1 is fixed. A1 cannot change the position, so it's fixed. Now we are left with 4. There are 4 art students, out of which 1 is fixed, and the remaining 3 are free to arrange among themselves. So the 4 art students can arrange in how many ways? They can arrange in 4 minus 1 factorial, that is factorial 3 ways, that is 6 ways they can arrange among themselves. Now once it is done, once the arrangement of the art student has been done, okay, now we have to arrange the the science students which are actually in between the art students, because the arrangement is an alternate manner. Now how many places are there? There are 1, 2, 3, 4, and there are 4 places and there are 4 science students. So there are 4 places and there are 4 science students. So the total number of such arrangement in that particular case will be 4p4, that is arrangement of 4 things by taking 4 at a time. So that means the number of ways you can arrange the science students after you have arranged the art students in a circular manner will be factorial 4. So the number of ways of arranging the 4 science students, okay, will be equal to 4p4, and that is actually factorial 4. So factorial 4 is the total number of ways that we can arrange the 4 science students after we have arranged the 4 art students in a circular manner in factorial 3 ways. Therefore, what is the total number of arrangement possible? The total number of arrangement possible will be again by the fundamental principle of permutation. That is, the total number of arrangements will be the total number of arrangements that is possible in this particular case, when they are saying that 4 art students and 4 science students will sit in an alternate manner, will be equal to, this will be 3 factorial into 4 factorial. That will give you the answer of the total number of ways by which you can arrange 4 art students and 4 science students alternatively at a round table. Okay. So, this is another application of this circular permutation. Okay. Now, in circular permutation there can be a problem. The problem is that let us say I just draw a figure to make things clear. Now, there is a concept called clockwise and anti-clockwise permutation. Clockwise and anti-clockwise permutation. Now, what is clockwise and what is anti-clockwise permutation? Now, we can draw a figure to make things clear. Let us say this is the circle we have drawn and this is the circle we have drawn, right. Now, let us say I want to arrange these 4 alphabets A, B, C, D, and here I arrange it A, B, C, D. Now, you see now this is the clockwise, this is the anti-clockwise arrangement and this is the clockwise arrangement. This is the clockwise arrangement and this is the anti-clockwise arrangement, right. Now, in case of an anti-clockwise arrangement, okay, and in case of a clockwise arrangement, this is the anti-clockwise, this is anti-clockwise, okay, and this is the clockwise arrangement, right. Now, when we are able to distinguish a clockwise and an anti-clockwise arrangement, okay, then there is no problem, because in that case they are different, because these 2 arrangements are basically different, right. But when you are not able to distinguish between them, okay, it may happen that you are asked to arrange some objects, okay, in a circular manner where you are not able to distinguish between the anti-clockwise and the clockwise arrangement, okay, then in that case these 2 become same. Now, if these 2 become same, what happens? The arrangement is considered twice. To avoid that, what we do is that the total number of arrangement in that particular case becomes factorial n minus 1 divided by 2. You see, I have written over there, that is when you are not able to distinguish between the clockwise and anti-clockwise arrangement. Let us say I have taken a very simple example to demonstrate this case, that find the number of ways in which n different beads can be arranged to form a necklace. Now, you see, beads are basically all same in or look same, right. So, when you are arranging a bead in a circle, okay, when you are arranging a bead in a circle, will you be able to distinguish that whether you have made a clockwise arrangement or whether you have made an anti-clockwise arrangement? Is impossible. So, since you are unable to distinguish the clockwise arrangement and the anti-clockwise arrangement, okay, between the beads in a necklace, so in that case the total number of such arrangement for arranging n different beads to form a necklace will be simply n minus 1 factorial divided by 2. So, this is the result that we take or consider when we find that when we are not able to distinguish between the anti-clockwise and the clockwise arrangement. This is if you are able to distinguish, then actually they are different. Okay, let us say I want to make arrangement with some person sitting in a round table. Now, in that case I can easily distinguish who is person B, who is person D. Now, the moment person B reaches here and the person D which reaches from here to here, this position, it becomes a different arrangement, right. But in case of beads, that is not possible. So, nobody can say that is a clockwise arrangement or is an anti-clockwise arrangement. That means you are not able to distinguish between the clockwise and anti-clockwise arrangement in some particular cases, like in the case of a beads forming a necklace. And in that case, what happens? The arrangements become same. And if the arrangements become same, then you have to divide the total number of arrangements, which was n minus 1 factorial divided by 2. And that is the result you should remember in case you are trying to solve problems where you find that the arrangements that you make in a clockwise and anti-clockwise manner are not distinguishable. So, that is all for today's class. We will be discussing more on this permutation and combination in next class. Thank you.